Good morning, good evening, good afternoon, or it can be good morning, good afternoon, good evening to everyone who is attending this event. Yes, this talk will be a Flutter talk. Specifically, I will be talking about more than just widgets. And okay, so I'm very pleased to be part of the very first International Women's Day for GDG and WTM Budapest, which is happening in collaboration with GDG and WTM Jeddah. Quick facts about me. Of course, I'm Nawal Alhamwi. This is my Twitter handle in case you have any question regarding Flutter, Dart, or even the talk that I will be presenting today. You can ask me any questions. I'm a Flutterista, I'm a Flutter developer as well, and a Women Techmaker ambassador, and I'm one of the leaders for the Jeddah chapter for Women Techmakers here in Jeddah, and I'm a co-organizer in GDG Jeddah. Okay, fun part. So, for who this talk is for. So basically, this talk is more suitable for intermediates in Flutter, but having beginners attending this talk is more than welcome as well. This talk is basically for everyone. So those who are beginners in Flutter, so Flutter is Google's UI toolkit for building beautiful, natively compiled applications for mobile, web, and desktop from a single code base. Why to care? So after this talk, you will learn, 1 second, let me use the, I'm not sure if it's here, most probably, there is no pointers, I think, in Zoom. Yes, you will get to learn how to create performant applications. You will get to learn the anatomy of Flutter applications. We will understand how reusable objects are actually reused in Flutter, and we will be able to understand how to debug your applications. So as we can see over here, this is a simple Flutter application composed of several widgets, like the container is composed of the row is composed of several columns, and the column is composed of an icon and a container, and the container is composed of a text. So this is the parent widget, and the rest of the widgets are the children. The container has one child, the row has several children, as we can see over here. The column has, again, several children. Again, container has one child, icon has no children or child. So let's say that the user wanted to change an icon or maybe the text in the container. So what the user will be doing over here is that is changing the UI, and we'll see why am I mentioning this example later on in the talk. I will be referring to this example several times. So like to translate this code into a real application, this is the translation for it. So as you can see, of course, it's very simple, but this simple UI is composed of several widgets. Okay, now let's start off with the very basic building block of a Flutter application. Actually, okay, let me just repeat the same sentence. So this is the basic building block of any Flutter application. Now, the Flutter documentation defines the widget as widgets are the immutable description of a user interface. They are descriptive views. Technically speaking, they are Dart classes that represent your UI on your screens. Now, Oxford Dictionary says that the word immutable means something that cannot change or will never change. Oops, what did I do? Let me just close this. Okay, so yeah, so widgets are immutable description of a user interface. So they are Dart classes that will represent our UI on our screens. And as I said, they are immutable, meaning they will never change. So probably now you're asking yourselves, the UI changes, but the widgets don't. How is this even happening? Like, it doesn't make sense. I will explain. Actually, Flutter manages this notion with the concept of trees. Now, I like to refer to the Flutter applications as one big gigantic iceberg. Okay, the tip of the iceberg is the widget, which we see on our screens. And of course, our application is made up of the rest of the iceberg. So there is so much into our application. It's not technically, yes, it's widgets everywhere, but there are more than just widgets. So what actually is there in our application is the rest of the iceberg, of course. Okay, so as we can see over here, this is from the documentation from the Flutter SDK in my IDE. Of course, it exists in any IDE as long as you have the Flutter SDK installed on your machines. So here, the Flutter documentation defines widget as being an immutable Dart class. Okay, so why are we using the concept of trees here in Flutter? If you developed applications using Flutter, you will realize that there is a hierarchical data structure, meaning that data is organized in nodes and they're connected by branches. So you have a parent that may have a child or children. Remember the simple tree that I've showed you at the beginning of the talk, where we had container at the top, and I told you that this is the parent widget. Then there were several. No, actually, so the parent widget, the container had a row, only one child, and the row had several children, and we saw that some widgets had one child, some widgets had several children, like the row and column, and some widgets had no children, like the icon widget. Okay, so what makes up the anatomy of a Flutter application? As we can see over here, this is the architecture layer for the Flutter framework. We interact most of the times. Here with the platform design specific widgets, basically the material widget for the Android platform and the Cupertino widget for the iOS platform. So us developers, we interact all of the times we interact with this layer, and we interact with this layer, which is the widgets layer. Then we have the rendering layer and the Dart UI library, which we deal with. Okay, of course we deal with those layers. However, we do not edit those layers, like in the widgets layer and the platform design specific widgets. Of course, we write everything from yes, we write everything from scratch, but not technically. Yeah, in the rendering and the Dart UI library, we don't write anything over here. It's handled by the framework. Okay. Now, each layer in our architecture or in our Flutter application's anatomy, each layer relies on the layer below it. Meaning, the platform design specific widgets cannot function without the widgets layer, and the widgets layer cannot function without the rendering layer. Again, and the rendering layer cannot function without the library. And the whole framework, the Flutter framework, which is written in Dart, cannot function without the engine, of course, which is written in C++. And small fact that we paint our pixels or the widgets that we see on our screens using the Canvas API, which comes from the Dart UI library. Awesome. Okay, so I had said earlier that the UI is mutable. Okay, so the UI can change. This is pure logic. It can change. However, the widgets are immutable pieces of data. So the widgets are pieces of data that cannot change. Now, Flutter manages this difference in concept using trees. So we have 3 trees in Flutter that manages the state of the mutable UI inside the immutable widgets. And these trees are the widget tree, the element tree, and the render object tree. And you can see over here that every emoji is different than the other. And there's a little tiny secret for it that I will reveal by the end of this talk. So stay with me. Okay, so again, back to our lovely iceberg. So yeah, the tip of the iceberg is for the, or I see it as the widget tree. Okay, so when you build up your UI's application, you're doing so, of course, in a declarative sense. The role of a widget is to explain to the framework, to the Flutter framework, how the elements will be arranged. Widgets are the abstracted logic that we see on our screens, whether it was layouts, styling, animations, you name it. You create a widget by composing other widgets, like the scenario that I've showed you earlier in this talk. We had the container widget, which had one child, the row widget, and the row widget had several children. So as you can see, we composed several widgets to create a single simple UI. And okay, so in a nutshell, the widget tree is the blueprint, okay? Widget tree is the blueprint tree of the elements tree, which can be or which will be rendered on our screens. Each widget, of course, it behaves differently with the element tree. The framework will ask the element tree to create an element for the requested widget that we want to create. When a widget responds to a change in an element tree, meaning when the user creates a change with the widget, this is the start of the widget's life cycle. Okay, so what's an element? An element acts like the manufacturer of a widget. What does that mean? Since, of course, as I said earlier, Flutter is a declarative framework, the element here declares or instantiates the widget in a certain location in the widget tree. So the element tree manages updating those immutable widgets. In that sense, we can consider the element as mutable component. Element tree makes sure that the UI is changing and responding to these changes by being updated. So the element tree is responsible of the life cycle of the widgets. Okay, element trees are there to make sure that when anything updates in your UI, things are well structured and organized. Moreover, for every element of a widget, there is a render object for it. And for every element, there is a reference. There is a reference of the widget configuration. In that sense, elements aren't created. Elements aren't recreated. However, they're updated. Let's say that I updated a widget in my material app widget. What happens in such a case? The element only updates the reference to that widget instead of being destroyed and created again. So the structure of our tree is the same, but it's amended. Now, to sum this up, only the widget gets rebuilt. However, the element updates only the widget's reference. In this way, Flutter is considered to be having performant applications. What's constantly being recreated are just cheap components compared to the element or even the render object trees. And that's because, of course, as I said earlier, widgets are blueprints, and blueprints are cheaper than the actual trees that are represented on our screens. So in a conclusion, for the element tree acts as a share point, or it acts as a glue that makes sure that the widget and render object tree are holding hands happily. Now, the last tree that we have over here is the render object tree. This is a special object called the render object, which is in the render tree. This tree is responsible of creating the layout of our UI, basically painting what you have declared onto our screens. The render object is responsible of giving constraints to the widgets that will be painted on the screen. What happens exactly in this tree is internally handled by the framework, and of course, us, the developers, we rarely interact with it. Remember the architecture that I've showed you earlier during this talk? And I told you that we don't deal, we deal with the render layer, but we don't amend or write anything in it. Okay, so each render object has a corresponding widget, of course, and we will see this more in the talk. In a nutshell, render objects methods, they are responsible of painting those bits and bytes of pixels on our screen. The render objects, they do the actual painting of the pixels on our screens. So this is why it's considered an expensive and complex layer. That's why we have 3 trees, so that we can reuse those expensive render objects. And I will show you everything in the talk. What do I actually mean in this? So we can conclude from this explanation that we have first the widget tree, then the element tree, lastly we have the render object tree in this specific order. Why? Because each tree is dependent on the other. We use the render object tree to paint our immutable widgets that exist inside the mutable element tree. What we're basically doing here is that we're getting the best of both worlds. How? By making sure that widgets cannot change their relationships with other widgets, otherwise our UI will get messed up. In fact, they need to get destroyed, then rebuilt, because of course, after all, they're cheap components, right? And the mutable element tree updates those changes. So element trees are mutable to change the state of these immutable widgets. Okay, some of you might be thinking, well, Nawal, okay, cool talk. Thank you so much for the information. But what if I don't have those trees? Well, in that case, you need to literally calculate the coordinates of every single pixel on your screen. Not only this, but also you need to update those pixels. That's why we have a high-level, abstractive, declarative approach to build our UI. We build our UI with widgets. So why is it important for us to know about the anatomy of trees? I believe it's a good practice as software engineers to know what actually goes behind the scenes, to be able to fully understand how things actually work, and thus it can help us in tracking an error to its root base and be able, of course, to debug it. And okay, so the main steps, the 3 main steps into creating our Flutter application will be 1, configure, 2, lifecycle, 3, paint. Okay, so in the configuration stage, when we configure our UI, we are writing widgets. You're assigning the properties to those widgets. And the element tree, or where the lifecycle is handled, the element tree is the manufacturer or the management team in your application. It's responsible of the configured UI, which is the widgets. And as I said, it's responsible for holding certain certain positions for in the tree for those widgets, and making sure that each child or children knows their appearance, and vice versa, of course. All of the updates and formation of the widgets occur in this type of tree. The painting stage, or the render object tree. I like to call this tree the Picasso tree. The UI is painted on the Canva, and in this stage, each parent, child, and children knows their constraints, painting, composition, and even sizing. One question that one question that you may be asking yourself right now is that why are we creating three different trees to create one application? By building our UI like this, our end result will be applications that are very performant because the framework itself won't keep on destroying and rebuilding its components. However, it will be reusing its components. Okay. So here's a simple example. We have a center widget that has only one child. So when you start your Flutter application, mainly your application runs or calls a function called run app. This run app function takes the widget that you gave it to it and places it in the root of the widget tree. The next thing that happens is that the Flutter framework asks the widget, okay, it asks the widget to create the single child, for example, here center. The framework will ask center, please center widget, create a single child render object element. And yes, it will happen. Afterwards, the Flutter framework will ask the element to create a render object for this widget. When when this happens and the render object is created, the widget will pass all of its configuration required to paint this widget. Of course, just a quick fact that center is an invisible widget, meaning you cannot see it. It will position your like whatever you put here. So basically, it will position the text that we have over here. And same thing goes here. So the framework will ask the rich text widget, please create a leaf render object element, and the framework again will ask the element, please create a render paragraph or a render object for this widget. And again, the widget will pass its configuration to this render object so that we can see this change or creation on our screens. The fun part is here. Now, the secret sauce, the fun part actually happens when change occurs. The secret sauce in Flutter, and we'll see this in a demo shortly, is that widgets get swapped for other widgets. When does this happen? It happens when the framework detects change by running a method called canUpdate method, which compares both the runtime types and the keys of both the old widget and the new widget. Let's say that if the runtime types and the keys of both widgets, the old and new, were identical, then in such a scenario, the widgets will get changed. Then the element will fire up a method called update render object method, so that to update the differences, of course. Okay. When it happens, when the element fires up the method, the update render object method, and afterwards the widget passes its new configuration to the render object method, we can see the new text on our screens. So here the text was hello Budapest. However, when the user wrote down hello GDG and WTM Budapest, the old widget got it got destroyed, and the new widget came. The new text widget came. Now, in this scenario, let me explain what happened over here. The change happens, and the change, of course, it happened, and now we can see it's reflected on our screens. We haven't changed our render objects. In fact, we haven't created or destroyed anything. We have just updated the values. See, we just updated over here. We just updated the values of the render objects, but we definitely changed the immutable widgets. Immutable widgets configuration. Note that the center widget have not changed. Look, it's the render object for it didn't change. Okay. Why did this happen? Mainly Yeah, so the render objects for the center widget didn't change. And that itself is a fact that Flutter doesn't throw its components away. In fact, it only changes what has been updated. In the center widget, nothing has been changed, right? So that's why we have the same render object. But in the rich text widget, yes, we have text that has been changed. That's why our render objects are changed. This is this like shows us how Flutter creates performant application. Let's jump quickly to the demo. Okay, so let me, oh, I didn't run it. Okay. So let me just tell you quick things here. So basically we have, one second, where is this? Okay, so let me just take this quick example. So we have the parent widget here, we have the children over here, we have this is, oh, okay. So this is, it takes, of course, as we have seen earlier in the figure that I've, no, one second, I'm explaining something. Yeah, so row can take several widgets. However, for demonstration purposes here, I will be only giving it one child, which is the text. And so basically we have the row, come on. We have the row and we have the text widgets. Both of them will go in the same process. Both of their runtime types and keys will be checked to see if they are the same as the old row. One second, let me just show. Okay, cool. So both of them will be checked, and Flutter will see that the row, of course, it hasn't changed. Only we can see that the text is changing. So row will be kept as it is. However, Flutter, of course, detects that there is a change in the text, so the new configuration replaces the old one. The can update method is evaluated to true, then it runs the update render object method. That's why we see the new text when I click this button. We can tell the render object hasn't changed because if we look, now I will show you now. Now I will show you the instant IDEs. Okay, so this is the text. No, I want the details. I will explain what is this. This is the details tree. So we can see over here, this is GDG Budapest. Please note down that the render object is of AF73E. Okay, AF73E. No, write this down. So this is the instant IDE for, instant ID for the render object of the text hello GDG Budapest. When I click here, now I have the hello WTM Budapest. When I refresh my tree, I want the details tree, please. We can see it's the same render, it's the same instant IDE, which is AF73E. And different text. I will do it again. AF73E. Hello GDG Budapest. Refresh the page. Go to the details tree. AF73. So this proves what we have learned today, which is when so the text runtime type and the keys were the same. Although we had different values, but at the end of the day, we are dealing with text widgets. Of course, all text widgets are the same, meaning they have the same runtime types, okay? And that's why the render object is not thrown away, only the UI is changed, only the immutable pieces of the Dart classes, which is the widget, only this is changed. Okay, so let's say, one second. So this is the dev tools or the Flutter developer tools. Briefly, briefly, this is a collection of tools for checking your your Flutter's application's performance and to debug it as well. I lost my track of thoughts. Oh yeah, I wanted to say something, which is, let's say I change the text widget to an image widget. Okay, so of course, text, image, they are different. What do I mean by different? They have different runtime types, of course, and different keys, right? So in that scenario, yes, Flutter will throw away the text widget and create an image widget with the different render object instant ID. Because of course, as I said, they are different widgets, right? Now the point is that if I want to change the image back again to a text widget, here Flutter won't use the same old instance IDE. IDE? What IDE I'm talking about? I mean ID, okay? So it will create another brand new render object for the new text widget that has been replaced instead of the image widget. That's it for today. I hope you enjoyed the. So basically, those are the resources. And again, that's it for today. Thank you so much for attending. I hope you enjoyed my talk and that you learned something out of it. In case you have any questions on my talk, perhaps I had maybe I went on it's oh my god. Okay, maybe I rushed in some points. If you have any questions on my talk or on Flutter or Dart, please do reach me out on my Twitter handle, _2_ Nawal Alhamwi. Thank you so much for coming today, and I hope you enjoy the rest of the event. Take care.